What makes some people learn faster, solve problems more effectively, or adapt more easily to new situations than others? Psychologists have long sought to answer this question, and one of the most enduring and influential ideas to emerge is the theory of general cognitive ability, often referred to as the concept of G. This theory proposes that a single underlying factor influences performance across a wide range of cognitive tasks, from reasoning and memory to language comprehension and problem solving. It suggests that intelligence is not just a collection of independent skills, but a deep, unifying capacity that supports all forms of thinking. The roots of this idea go back to the early 20th century when British psychologist Charles Spearman analyzed correlations among different mental ability tests. He noticed that individuals who performed well on one type of cognitive task, such as mathematical reasoning, tended to perform well on others, such as verbal comprehension or spatial reasoning. This pattern led him to propose the existence of a general intelligence factor, a kind of mental energy or capacity that underlies all intellectual performance. In addition to this general factor, he also acknowledged specific abilities unique to particular domains, such as musical or mechanical skills. The G factor was a revolutionary concept because it provided a measurable framework for understanding human intelligence. It implied that cognitive abilities are interconnected rather than isolated. Modern psychometricians have supported this view through factor analysis, a statistical method used to identify patterns among test scores. Even with advances in neuroscience and data modeling, the general intelligence factor continues to emerge as a dominant explanation for differences in intellectual performance. Later researchers expanded and refined Spearman's work. Raymond Cattell proposed that general intelligence consists of two related but distinct forms: fluid intelligence and crystallized intelligence. Fluid intelligence involves the ability to reason, solve novel problems, and adapt to new situations. It is independent of learned knowledge and tends to peak in early adulthood. Crystallized intelligence, by contrast, reflects accumulated knowledge, vocabulary, and experience, which typically increase with age. Together, these two forms of intelligence shape how individuals think, learn, and interact with the world. The biological basis of G has also been a subject of deep exploration. Neuroscientific studies using brain imaging techniques such as fMRI and PET scans have shown that individuals with higher general intelligence tend to exhibit more efficient neural processing and greater connectivity across brain regions, particularly in the prefrontal and parietal cortices. These areas are associated with attention, working memory, and complex reasoning, key components of intelligent thought. The brain appears to function not by having isolated centers of intelligence, but through integrated networks that allow for flexible and rapid problem solving. The theory of general cognitive ability also has practical implications in education, psychology, and the workplace. Standardized intelligence tests, such as IQ assessments, aim to measure this underlying factor, providing insights into learning potential, cognitive strengths, and areas for development. While the predictive power of G is well documented, correlating strongly with academic success, job performance, and even life outcomes, it remains a topic of ethical debate. Critics argue that an overemphasis on a single intelligence measure risks ignoring the diversity of human abilities, creativity, and emotional intelligence that cannot be captured by a numerical score. Modern researchers have sought to integrate the theory of G with broader frameworks of intelligence. Theories such as Howard Gardner's multiple intelligences and Robert Sternberg's triarchic theory challenge the idea that a single factor defines human intellect, emphasizing instead the multifaceted nature of human capability. Yet, even within these broader models, the concept of a general cognitive foundation remains relevant, suggesting that while intelligence expresses itself in many forms, it may still be rooted in shared mental processes. Ultimately, the theory of general cognitive ability provides a powerful lens through which to understand human potential. It reflects the idea that intelligence is not merely a skill to be learned, but an underlying capacity to learn itself. From the earliest experiments of Spearman to today's brain mapping technologies, the search to understand G continues to reveal the remarkable unity beneath the diversity of human thought. Intelligence, in this sense, is the silent architecture of the mind, a hidden thread connecting every act of reasoning, memory, and discovery.